This topic is about sketching combinations of transformations and labeling all key information such as asymptotes and intercepts with the axes. You need to be able to recall all different transformation notations. So for example, here you need to remember all these different types of transformation. So f of x plus a with x plus a in a bracket is a translation by the vector minus a0. F of x plus a with a outside the bracket is a translation by the vector 0a. F of negative x is a reflection of f of x in the y-axis. Negative f of x is a reflection of f of x in the x-axis. F of ax is a horizontal stretch of scale factor 1 over a, and a times f of x is a vertical stretch of scale factor a. So these things you have to remember as you're doing this topic. Okay, so we're looking at very complicated combinations of transformations. So when you're transforming things of the form a times f of bx plus c plus d. So here you can see there's four different things going on. And we need to decide in which order we need to do this transformation. The first thing we need to look at is which things transform in the x direction. So everything inside the bracket affects the x, remember, coordinate. So it's the b and the c. So we're going to isolate and look at f of bx plus c to see which order we need to do f of bx plus c. So if we look at that, so there's two different cases we need to look at. Obviously, do we do b and then c, or do we do c and then b? So when we have f of bx plus c, which one do we do first, b or c? Okay, so obviously we always start off with the original function, the root function or the initial function, which is f of x. Let's say we apply b first. That means we get f of bx. Now, what does that do to our graph? That is a horizontal stretch. So that's a horizontal stretch by scale factor. Remember, because it's x that's affected, it's the reciprocal of b, so 1 over b. So when we do a horizontal stretch by scale factor 1 over b, we get f of bx. Now, if we apply c to it, so c, what does c do? C is a translation by the vector negative c, 0, because remember again, the opposite thing happens. Then when we do that, what we end up getting is f of b of x plus c. Now, does that look like what we have there? What we have here? It doesn't, because here, if you look at what we have here, we've got f of bx plus c. Here we have x plus c in a bracket. So that's not the same thing. So it's not b before c. Let's look at c before b. What happens when we do c and then followed by b? So if I do that case, what I end up getting is f of x. If we apply c first, it's the same thing as getting f of x plus c, which is a translation by negative c, 0. Then if we apply b, so if we apply b next, then wherever we see it, x replace with bx, so you get bx plus c. This is a horizontal stretch by scale factor, remember, 1 over b, reciprocal because the x being affected. F of bx plus c is what we wanted, so that is correct. So to summarize, if I want to summarize this, is if f of x is the initial function or the root function, the function that we started with, we always apply c first, followed by b to get f of bx plus c. So the main thing is c before b. Okay, let's do the same thing with everything that affects the y. Okay, so if we do the same thing with the y now, so if we're looking at this, remember this complicating thing, a, b, c, d, then the thing that applies the y is obviously the constant that are outside the bracket, which are a and d. So when we're looking at transformations in the y direction, we're just looking at a times f of x plus d. Okay, so we need to look at, do we do a before d in this case, or do we do d before a? So let's look at a before d. So if we're doing a before d, and then let's look at d before a. These are two options. Let me just go and highlight here a before, b before c and the c before b. Okay, so we're looking at this case. So a before d and then d before a. So remember, our initial function is always f of x. And then we're applying a to it. So we're going to get a times f of x. Let's do that. When we do a times f of x, we get a vertical stretch. And because it's the y that's being affected, it's the same scale factor by scale factor a. Okay, then we're applying d. When we apply d, we get a times f of x plus d, because we're adding d on. So this is a translation by the vector 0, d. And if you look at this, this is the same thing as what we wanted. So that looks like it's giving us the correct thing. So if we do a before d, it looks like we're getting the right thing. Let's do d before a, see what we get when we do d before a. So remember, our initial function is f of x. Imagine we apply d to it, then it's a translation by, remember, it's 0d. So then you get f of x plus d. So I'm going to have to go here. Then if we apply a to it, then that means we get a times f of x plus d, which is not what we want, because that does not look like what we wanted. So that was, remember, a vertical stretch by scale factor a. So this is not what we want. So that means we do a before d when we're looking at the transformations that affect, obviously, the y in the y direction. So if I want to summarize, if f of x is the initial function, apply a first, followed by d to get a times f of x plus d. So to summarize, you do a and then d. Now, because the effects of the x in the x direction and the y direction are obviously isolated, as long as you do a before d and c before b, you will get the correct transformation. Okay, so in this, if I had to summarize everything, when you are transforming a times f of bx plus c plus d, which order do we complete the transformations? We need to transform c before b and then a before d. So that means you can use this acronym CBAD, c before b, a before d, to memorize it. But that's not the only way you need to transform, although this is the, I'm going to say this is the way, this is the acronym you should use. You can have any transformation where you have c before b, a before d is enough. So another combination could be c, a, b, d, because in this case you have c before b, a before d. Or it could be c, a, d, b. So c before b, a before d. It still works out. Or even a, d, c, b is still a before d, c before b. A, c, d, b, a before d, c before b. Or the case a, c, b, d. A before d, c before b. So it does work out. But the one that I want you to really use is c before b, a before d, because it's quite easy to remember CBAD. CBAD. Okay, let's look at some problems. So example problem 1. Suppose that you want to graph f of x is equal to 3 times root x plus 2 minus 7. In what order can you perform the transformations to obtain the correct graph? So I'm going to do is highlight to see what the initial function is. So we can see if I cross out the constants, You're just left with root x. So your initial function, if you want to write it down, that you start off with, which is a standard one that you should know, is f of x is equal to root x. And that's being transformed to get that one. Okay, now we need to label which one, what these constant represents, a, b, c, or d. So this one, because it's in front, it must be a. There's no b here. B is 1 times x, so we don't need to worry about b. This is c. The minus plus 2 is c, and this part must be d. The minus 7 must be d. So remember, we've got the case C bad, C, B, A, D. So in this case, we don't apply the B. Okay, so if we're going to talk about the order will be first apply C, so the plus 2 there. So that means it's a translation. So it's the x that's being affected. So it's a translation by the opposite in the x direction. So minus 2, 0. Okay, next is A. So A, what effect does 3 have? 3 is a stretch. It's a vertical stretch because it's outside the bracket. So then you do a vertical stretch by scale factor. It's a 3 and it's outside the bracket, so it's affecting the y, so it's just 3. Then now we're doing D, which is minus 7. Minus 7 affects the y, so it's translation again. By this time it's in the y direction, so it's by 0, minus 7. So that would be the order in which I transform the initial function to get this function that I want here. Okay, now just to note, you can combine the true translations together because it doesn't matter. So if you wanted to, alternative, if I want to write it down, as long as you did C before B, but there is no B, A before D is fine. So what you can do a vertical, so you have to do the A first, so the alternative, as long as you do A before D, so you have to do a vertical stretch by scale factor 3 is fine, but then you can combine the two translations because it doesn't matter that C and D can be performed together. So translation by minus 2, minus 7. What you can't do is put the translation first because then D would come before first A, so you can't do that. Okay, let's look at example problem 2. It's a similar one. So again, it looks like the root function or the initial function is f of x is equal to root x still. Okay, so let's label what we have here. So we've got a negative here, we've got the plus 2 here, and we've got the minus 7 here. So there is no a because there's nothing in the beginning. So b is obviously minus 1 because there's a constant of minus, sorry, there's multiple of minus 1 there. C here and D. So remember, we're looking at C bad. Then we don't have the A in this case. So the first thing we need to do is C. So order. Do C first. What does C do? It's a translation in the x direction. So translation by the opposite of 2 is negative 2 when you translate it. So translation by negative 2, 0. Okay, next is B. So what effects does negative x have on, obviously, transformation? It's because we're timesing x by minus 1, it's a reflection. And the x's are changing sign, so it's a reflection in the y-axis. The next one is D, which is minus 7. This is a translation in the y direction by negative 7. So translation by 0, minus 7. Okay, I'm not going to write alternatives out. There's many alternatives. I'm just going to use CBAD to get my answers. Okay, example problem 3. So suppose that you want to graph f of x is equal to 5 over 2x plus 1 minus 3. In what order can you perform the transformations to obtain the correct graph? So if I highlight again, we've got a 5 there, we've got a 2 there, we've got a 1 there, we've got a minus 3. So you can see the initial function is what remains, which is equal to 1 over x. So it's just a reciprocal function. So in this case, you can see if I just write down CBAD. Okay, this is your A, this is your B, this is your C, this is your D. Okay, so order would be first is apply C, which is a translation. So translation in the x direction by -1, so -1, 0. Next is B, which is the 2 in front of the x, so this is a horizontal stretch by the reciprocal of 2 by scale factor 1/2. Then is A, which is the 5. That's a vertical stretch because it's multiplying outside the bracket. So vertical stretch by scale factor, because it's a vertical stretch, it's the same number, so by 5. And the last step would be the -3 at the end, which is a translation in the y direction by -3. So translation by 0, -3. For part B, so that's it. Part B says graph the function. Okay, if I'm graphing the function, I'm going to do it in mini graph step by step. Okay, so the initial function is 1 over x. So that's what I will start drawing. So 1 over x is a reciprocal function, like so. So this is x and this is y. And if I were to label the asymptotes, which is the key feature of a reciprocal graph, that is x equals 0 and that is y equals 0. The first thing I need to do is translate by -1, 0. So that means I need to move in the x direction by -1. So what happens is the asymptote moves to, because if I'm moving everything to the left by -1, it moves to x equals -1. The horizontal asymptote is still the same. So it look like so. Okay, next step is after horizontal stretch by scale factor 1/2. So horizontal stretch by, so this is x, sorry, and this is y. Okay, so horizontal stretch by scale factor 1/2 means my asymptote will no longer be x equals -1. It will be times by 1/2, so it's going to be x equals -1/2. My vertical one will be x is equal to -1/2. And my horizontal asymptote will still be the same, so it'll still be y equals 0. The shape, because we're not drawing to scale, will roughly be the same as a sketch here. Okay, next thing I need to do is a vertical stretch by scale factor 5. That won't change it by much because the only key feature, so if I go here, so 1, 2, that's the next one, x and y. So my horizontal asymptote won't change because y equals 0. If you times it by 5, it's still y equals 0. And this one will still be x is equal to -1/2. So it'll look like so. And the last thing I need to do is translate by 0 -3, which means the graphs will shift down by 3 in the y direction. So now my horizontal asymptote will be at y equals -3, it's going to move down by 3, and my vertical asymptote will still be at x equals -1/2. Okay, if I were to draw it, then it'll look something like this. And this one will look something like this. There's going to be 2 intersections, so we need to label this A and B. Okay, so if you want to know what A is, at A we know x is equal to 0, which implies y is equal to 5 over 2 times 0 plus 1 minus 3, which means y is equal to 5 minus 3, which is equal to 2. So y is equal to 2. So that is 0, 2. A is equal to 0, 2. For B, what we do know is y is equal to 0, which implies 0 is equal to 5 over 2x plus 1 minus 3, which means if I rearrange it, 3 is equal to 5 over 2x plus 1. which means 5 over 3 is equal to 2x plus 1. Take away 1, I get 2 over 3 is equal to 2x. So x is equal to a third. So b is equal to a third 0. So a third 0. Okay, next question. Sketch the following functions in each equation. In each question, decide what the root function is. Okay, let's call this A, B, C, and D. Okay, so for A. Okay, so A, if I'm highlighting, this is my A, B, C, and D. That means my root function, initial function, is y is equal to x cubed. And I'm doing, remember, CBAD. Oops. CBAD. So this is A, B, C, D. So C is a, first you need to translate by, because it's a minus 10, it's going to be by 10, 0. Then we need to do CB, which is a horizontal stretch by the reciprocal, so by scale factor a half. Then we need to do A, which is a vertical stretch by scale factor 3. And the last one is translate D, which is translate in the y direction by 0, 4. So because we're moving it up by 4. Okay, so mini sketches for each one. So first it's y equals x cubed. So y equals x cubed. Xy is going to go through the origin. So this is y equals x cubed. Then we're going to translate by 10, 0. So when we translate by 10, 0, it's in the positive x direction. So it's going to look something like that. We don't want to label everything at this point because it's just useless. So this is y equal to x. We're not going to label the graph as well because that's going to take long. So we just do the transformation for each stage. Okay. Next thing is horizontal stretch by scale factor a half. So that means x-intercept of 10 will half. So it's going to be going through 5 now. Okay. Vertical stretch factor by 3. Now, because there is no significant point at the moment, it's just a stretch, so the x-intercept won't change. So let's just draw it very similarly, going through 5. And the last step is translate by 0, 4. If you're translating by 0, 4, you're shifting it up, so that twisting will happen at 5, 4. You're going to have that twist, and all we need to do is find the intercept. So it's going to do a twist here, and it's going to go like that and like that. So we need to find these 2 points. Let's call these points A and B. So if we want to work out A, at A we know x is equal to 0, which implies we get y. Going back to the equation, y is equal to 3 times minus 10 to the power of 3 plus 4, which is equal to minus 3000 plus 4, which is minus 2996. So A is equal to minus 2996. So this is 0 minus 2996. At B, we know y is equal to 0, which implies 0 is equal to 3 times 2x minus 10 cubed plus 4. If we rearrange it, I get 2x minus 10 all cubed is equal to minus 4 over 3. I'm just going to rearrange in multiple steps. So that means I'm going to get minus 4 over 3 cube rooted first. Then I need to add 10. Then I need to divide by 2. If I put that into my calculator, I get x is equal to 4.44 0.49 going endlessly. X is roughly 4.45. So B is 4.450. Okay, so that's A done. So this is my final answer, this one. Okay, let's try B now. Okay, so if I look at B, if I highlight what I have, got 2 there, we've got the 4 there, we've got the minus pi over 2 there, and the plus 1. So it looks like the root function or the initial function is y is equal to sine x. Okay, so again, we're doing C bad. So here we've got A, B, C, D. So C tells us it's a translate in the x direction by the opposite thing. So translate by pi over 2, 0. Okay, next thing is B is a horizontal stretch by scale factor a quarter, because it's the reciprocal of 4. Then it's A, which means it's a vertical stretch by scale factor 2. And the last thing we need to do is translate in the y direction by 0, 1. Okay, so let's do the mini sketches. So I'm only going to draw from 2 pi to minus 2 pi. Okay, so sine x looks like so. It's going from 1 to minus 1. Okay, I need to translate it by pi over 2, 0, which means everything that moves in the x direction by pi over 2, which means I end up getting everything moves by pi over 2. It means I end up getting this shape and this shape between 2 pi and minus 2 pi. Okay, again, the minimum is minus 1, the maximum was 1. If you want to label 2 pi and minus 2 pi. Here it was 2 pi and minus 2 pi. Okay, next is a horizontal stretch by scale factor a quarter. What that means is I'm going to have to squash it by... So here we've got 1 repetition in 2 pi. We're going to get 4 repetitions now. So if I want to draw it out, it means I'm going to get 1, 2, 3, 4, and 1, 2. Oh, this is really bad drawing. Let's try again. I might need to make it longer. This is 1, 2, 3, 4. We're going to get, so this is 2 pi. And here we're going to get 1, 2, 3, and 4. So this is minus 2 pi. Again, going from 1 to minus 1. Okay, vertical stretch by scale factor 2 means you're going to get the same shape, but it's going to go from 2 to minus 2. So if I want to draw it in here, y and x, same shape still, 1, 2, 3, 4. This is 2 pi, and 1, 2, 3, 4. This is minus 2 pi. Then it's going from 2 to minus 2 now. Okay, and last step is translate by 0, 1, means everything shifts up by 1. So if I draw the last one here, everything shifts up by 1 is going to go start at 1 and then go to, so minus 1 and go to 3. So it's going to be 1, 2, 3, 4. Again, this is 2 pi. And 1, 2, 3, 4. And this is minus 2 pi, going from minus 1 to 3. So your final answer will be this one. Okay, let's look at C. So C, if I highlight it, we've got 3 there, we've got a 2 there, we've got a -1 there and a 4 there. So the root function looks like it's y is equal to 2 to the power of x, and we're doing C bad again. Then the first thing is, if I label it A, B, C, D, C is a translation, so translate by, it says -1, so that means it's going to be 1, 0. And then it's B, which is 2x, so it's a horizontal stretch by scale factor, the reciprocal of 2, which is a half. Then it's A, which is 3, so it's a vertical stretch by scale factor 3. And last thing is the D, which is +4, so translate by 0, 4. Okay, so let's look at these ones. C is so 2 to the power of x first. 2 to the power of x looks like so, going through 1, asymptote at y equals 0. Okay, if I sketch the next one, which is translate by 1, 0, everything moves in the x direction by +1. So the asymptote does not change. So the asymptote is still at y equals 0. But everything's moved forward. So it's just going to be like this. It's no longer going to go through 1. It's going to go through, if I substitute 2 to the power of -1, I get a half, so this one will go through a half. Okay. Okay, next thing is I need to do a horizontal stretch by scale factor a half, so that doesn't change much. So x, y is still going to go through a half. It's just the scaling is going to change, but it's a sketch, so it doesn't matter. So, oops. So your asymptote is still y equals 0. Next one is a vertical stretch by scale factor 3, so that asymptote won't change. Asymptote won't change. But the y-intercept will, and instead of being a half, it will be 3/2. So go through, 3/2. But the asymptote will still be at y equals 0. And the last step is translate by 4, 0, which means everything's going to go up by 4. So 0, 4, by 0, 4, which means your asymptote will no longer be y equals 0. It will be y equals 4. Okay, and it'll still be similar looking. The only difference is instead of 3/2, you have to add 4 to that, which is 1.5 plus 4, which is 5.5, which is 11/2. So we'll go through 11/2 now. So that's your final answer. I don't have space for D, so I'll have to go somewhere else. So if I highlight this, I'm going to call this all A, this is B, this is C, this is D. So A, B, C, D. I'll have to go here to write. I'll have to go here, yeah. For D. Okay, so the root function, it looks like it's y is equal to the 1/x. So y is equal to 1/x is the root function. So this is D. Okay, so again, we're doing C bad, C, B, A, D. So the first thing we need to do is C, which is +5, which means it's a translation in the x direction by -5, 0. Then we need to do B is -2, so it's a horizontal stretch by scale factor -1/2. Okay, then it's A, which is -3, so it's the vertical stretch by scale factor -3, and then D is +7, so translate by 0.7. Okay, so root function is 1 over x again, so we've done it 1 over x. What's the second example with 1 over x? Okay, so first one is 1 over x, which will look like this. Asymptote are y equals 0 and x equals 0. So this is x and y. Okay, first thing I need to do is translate by -5, 0. So that means everything shifts to the left, which means, second diagram, x, y. So my horizontal one is still y, asymptote is still y equals 0, but my vertical one will be x is equal to -5 now, because it's moved down by -5. Okay, so it looks like, undo. So it looks like this. Okay, so it's moved. Next thing I need to do is a horizontal stretch by scale factor -0.5. Okay, if it's -0.5, it's going, my asymptotes will multiply. My vertical asymptote will multiply by -0.5. So the next one will be x, y. So my vertical one will stay the same. So my horizontal one will stay the same, which is y equals 0. But my vertical one will become, because it's x equals -5 in the previous one, it will be x equals to positive 5 over 2. Positive 5 over 2. And because there's a negative involved, it's going to be a reflection. So it's now x is equal to 5 over 2. And now they'll flip over. So this one will go through here, and that one will go through there. Okay, next one is a vertical stretch by scale factor -3. So my asymptotes won't change for this one, because when we multiply y equals 0 by 3, we're still getting y equals 0. So this is x, this is y. So y equals 0 stays the same. X equals 5 over 2 stays the same. The only difference, because we're multiplying by -3, a negative number is going to be a reflection as well. Obviously, because we're changing the y values, it's going to be a reflection along the x-axis, so it's going to go back to looking like so. Okay, last thing that we need to do is translate by 0.7, which means it needs to go up by 7. If it goes up by 7, my asymptote will now be at y equals 7. So somewhere at y equals 7, and my other asymptote will be at x equals 5 over 2 still, which is x equals 5 over 2. So if I draw it out, it'll look like so. All I need to do is find these 2 points, which is A and B. Okay, so at A we know, so here, if I go here, at A we have, at A we have x equals 0, which implies it's going to be -3, y will be equal to -3 over -2 times 0 plus 5 plus 7, which is equal to -3 over 5 plus 7, which is equal to 7 take away 0.6, which is equal to 6.4. So this will be 6.4. At B, y equals 0, which implies x 0 will be equal to -3 over -2x plus 5 plus 7. If I rearrange this, I get -7, -3 divided by -7, which is 3 over 7 must be equal to -2x plus 5, which means x must be equal to 3 over 7, take away 5, divide by -2. If I input that into my calculator, I get x is equal to 16 over 7. 16 over 7. So that means b is equal to, there is equal to 16 over 7, 0. Okay, one last question. The graph of the function y is equal to 2 to the power of x squared minus 4x plus 3 can be obtained from the graph of y is equal to 2 to the power of x squared by a series of transformations. Describe the transformations in words. Okay, so y is equal to 2 to the power of x squared minus 4x plus 3 can be rewritten by completing the square as 2 to the power of x minus 2 squared minus 4 plus 3, which is the same thing as y is equal to 2 to the power of x minus 2 squared minus 1, which can be written as y is equal to 2 to the power of x minus 2 squared times 2 to the power of minus 1, which is the same thing as y is equal to 2 to the power of minus 1. It's just a half. So it's just a half times 2 to the power of x minus 2 squared. So if you let f of x be equal to 2 to the power of x, then y here is equal to half of f of x minus 2. Okay, so that is what it is. Now, half is obviously equal to, in CBAD, equal to d. So this is just d, and this is, sorry, a. This is just a, because it's just in front of half. So this is a. There's the invisible one for of x, which is b. We don't care about that. And minus 2 is c. Okay, so CBAD tells us c first. So first thing we need to do is to transform to obtain y is equal to 2 to the power of x squared minus 4x plus 3, plus 3, from y is equal to 2 to the power of x. First thing we need to do is translate by 2, 0. And then perform, the half means it's a horizontal stretch, a vertical stretch, sorry. It's outside the bracket, so it's to perform a vertical stretch of scale factor a half. Okay, so we need to translate by 2, 0 first, and then perform a vertical stretch of scale factor a half. Okay, what I want to really highlight is when I was doing the previous question, the importance of doing mini sketches when you're doing a combination of transformations.